Good evening. Happy Wednesday. My name is Takiwa Smith. I'm founder and executive director of Engineering and Mathematics Link Incorporated, and I want to welcome you to our Math and Science Career Academy Teen Science Cafe. The goal of the Teen Science Cafe is to introduce teens to various STEM career paths. Most of these career paths in our Teen Science Cafe are real world STEM, and we want to do this at a time in your educational experience when you're making decisions about what you want to do after you graduate from high school. So if you're in middle school, to learn what high school you want to go to, what STEM activities you may want to participate after school, at your school and in your communities. In high school, maybe what more electives, what you want to major, but just giving you this time where you're older and you can start making decisions about what you want to do for a career and start researching the take to pursue that, whether it's associates, technical, bachelor's, school. We hope that these cafes give you opportunity to see a path that is possible for you, learning about the journey of a STEM professional. So, excuse me, without further ado, I'm going to introduce Carlin Pounders, our program coordinator, that is going to introduce today's speaker.
Thank you, Takiwa. Hi, everyone. Thank you for joining us. Today's speaker is Samantha Dickey, who is a makeup scientist with over 19 years of skincare formulating expertise and more than 28 years experience in manufacturing. She develops innovative luxury beauty products and training for brands across the United States. So without further ado, we are looking forward to Samantha sharing with us today about makeup science.
Hi, everyone. Thank you so much for inviting me, and I am so excited to be here to talk to you about cosmetic science and makeup science. And in my journey, basically from being a D physics student in high school to a dream job of manufacturing and innovating cosmetics that you love. Okay, so we're going to get started. I'm going to share my screen and just give you the background. And then after I give you the background of kind of how my career has evolved to get me to this point, I'll do a short demonstration on how we blend pigments and how we innovate makeup and cosmetic colors. Okay, all right. All right, so again, this is the journey of my career from colas to cosmetics. And I'll explain what that's all about here right now. So my career is a soft drink lab technician manager to a skincare lab manager / engineering technologist. And again, I'm just so thrilled that you're here and interested in discovering cosmetic science. And I'd like to also say thank you for exploring cosmetic science. And I'm just going to reiterate and let you know that, yes, I was a D physics student in my senior year in high school. So again, when I was a senior in high school, my physics teacher told me that I was going to get a D on my midterm if I did not get an A on the next test. So since that was unacceptable to me at the time, I studied a little bit and I got an A on the test. And it wasn't until that moment that I understood that I was really a great science student and a math student. I just didn't know. So when I got to college, I tried a course called Intro to Engineering Technology, and I instantly found my place there. It was kind of like in high school, I had been trying different things. I tried a business class and I tried a sewing class. I tried all of these other things, and I just wasn't sure what I wanted to do. But when I got into that intro to engineering technology, it was a perfect fit. So one of the reasons why I do this type of work and talk to students, especially teenagers, is because it might be your thing and you just don't know. So I'm here to say, give it a try, because it might be, something that's kind of innate in you. So just a quick overview of engineering. Basically, you're probably already engineering something, because engineering is the technique behind everything that we see and do. It's what takes a thought and makes it a thing. So that's the beauty of engineering, is just about everything that you think of is an engineering field. And if you're very particular about a sport or some area of study or a hobby, there's some engineering behind it, and you can enter that particular field through the field of engineering. So just really quickly, engineering is mechanical engineering, it's aerospace, it's biomedical. These are kind of the things that we think of when we think of engineering. It's civil. Civil is bridges and roads and speed limits. It's structural, architectural, electrical. That's what I majored in, electrical engineering technology. It's computer and robotics. It's chemistry, it's chemical. It's environmental. That's a really big one. And it has been a large field for quite some time now, because we are concerned about the environment in our planet. And so environmental engineering manages and innovates in that area. There's paper engineering, software, management, industrial, manufacturing, which is what I also do, is manufacturing engineering. How do we make things in an efficient manner that's cost effective to get the quality of life improved for the people in our communities? There's petroleum, geological, the list goes on and on. But there's traffic engineering, supply chain, which is huge right now. Like getting something from one side of the globe to the other, or from one city to a small rural town. Like, how does that happen? There's engineering involved in that. There's thermal, there's sports engineering. Like, all of the really great athletes are involved in some type of sports engineering that says this is the technique on how you do the thing. Whether if you're doing hurdles, there's a technique for hurdles. If you're a gymnast, there's a technique for doing a front handspring over the vault. There's all of these techniques that have to happen in sports, but there's also just the facilities of sports, the turf, and on a football field, the lighting, the chains, the everything, all of those things that goes into making something a thing is engineering. So in a nutshell, engineers solve problems just using some math and science. You don't have to be good at all the math and science, just kind of the one that you're working on. And I like to highlight Imhotep as the first engineer as a pyramid architect. And just, you can see on the screen, there's lots of STEM jobs that are, jobs of the future. So like having an understanding and appreciation, a joy for, some areas of science, technology, engineering, and math is amazing for our future. So my story. I went to South Carolina State University in Orangeburg, South Carolina. When I got there, I was unsure of what I wanted to major in. So I was at the gym and the registrar said, hey, there's a class called Introduction to Engineering Technology. Why don't you give that a try? And I did, and I fell in love instantly. So while I was at South Carolina State, I did 2 semesters at the Savannah River site. So I did a cooperative education assignment with the Department of Energy. And I worked in industrial safety. I worked around fire safety engineers, nuclear engineers, and environmental engineers. And again, the reason I'm bringing this up is to not list all of these things that I did. I bring them up so that you can see and hear the different types of engineers that there are. Because a lot of this work is done behind the scenes. So you don't see that there's actually a whole genre of fire safety engineers that go to different buildings and make sure that they're fire safe, and industrial safety, and nuclear, and also environmental engineering. These types of engineering are very prevalent. So I was still in college after those 2 semesters, and thanks to a college classmate, I did an internship doing AutoCAD, which is computer-aided design for a soda manufacturer. And what computer-aided design basically does is like blueprints. So when you see a blueprint, that's AutoCAD. That's using computers to draw things to scale. So I can freehand something and draw it, but when I use AutoCAD, I'm drawing it to scale. So it could be, miles and miles and miles long, but I have it on a small 8.5 by 11 piece of paper, or 11 by 17 or something else, to scale so that I can see like what it actually looks like in a manner that I can touch and feel, or I can maneuver things around and make efficient choices about what's going to go where. And so that's what I did. I did a layout for over-the-road trucks, and I did it to minimize wear and tear on wheels, because this particular soda manufacturer delivers a lot of soda using trucks, and they spend a lot of money on truck tires. And so the less turns and things, the less friction and less wear on the tires there would be, and they would be able to use that particular asset longer if everything was done intentionally as far as where the trucks were being parked. And so that's what I did. AutoCAD is a really, really good skill to have, because almost every company, or even just an entrepreneur, needs to have that information. And when you know how to do AutoCAD, it allows you to do that for the person that you're benefiting, or the group. So I call this next part soda pop science, because after I graduated, I began working for that same soda company at the plant as an operations management trainee. And there I learned about warehousing, production, quality, distribution, and sales. Doesn't seem like a whole lot goes into making a can of soda, but there are so many things that have to happen. Even warehousing is a huge industry. Even right now, if you think about Amazon and how they deliver, they're doing that based off of warehousing and logistics, and how they get things so quickly from their website to your door. And so these skills are things that you're benefiting from and you're experiencing, but you may not know that it's actually occurring somewhere in massive, massive numbers. So if you like organization and things like that, this like warehousing could be something that is totally up your alley. So we're going to talk a little bit more about some of those. So the first thing I did working at this soda manufacturer was a warehouse supervisor. And this position is at the time was responsible for loading trucks. So the hours were 4 p.m. to 2 a.m. It's kind of like a second shift kind of job. And at that job, I managed about 20 team members that loaded route trucks and over-the-road trucks. So I like to put this here because that there's a lot of work that's being done on other shifts other than the day shift, Monday through Friday, what they call 9 to 5. There's lots and lots of jobs that only happen on the weekends. There's jobs that happen Tuesday through Friday. There's jobs that happen from 4 p.m. till 2 a.m. There's jobs that happen from midnight to 8 a.m. So I like to let teens know that if you are a night person or a morning person, there's work out there in engineering and even in other fields that fits exactly into the hours that you feel most gifted. So you don't have to change. You just may have to explore some of the opportunities so that you can work during a time that you thrive in. So I actually like this time of day to work, that 4 p.m. till 2 a.m. Because you get home about 2:30. You can kind of sleep a regular day, get up around 8 or 9, and kind of do regular things throughout the day, and just go to work at 4 o'clock. So I really enjoyed that type of work behind the scenes as a warehouse supervisor. And then we had the production supervisor, and lots of responsibilities here. So here, I worked with depalletizers, conveyor, which you can see here in the picture, all this conveyor here, fillers, which you see over here and how the beverage bottles were filled, carbo coolers, which are over here, warmers, packers, cappers, video jets, and more. So this position covered like 3 shifts, right around 6.5 days a week. So I didn't work all 3 shifts, but I would kind of go from shift to shift. Sometimes I would kind of schedule myself, like maybe Monday and Tuesday I worked the first shift. I might take a day off in the middle of the week and then work a second shift, maybe work a third shift, to kind of be there with the team members, while they were there doing the work. So that's a very flexible position, and very, very demanding, because even when I was not at work, I was still responsible for the work that was going on. So that meant that I had to have a lot of processes and procedures that allowed stuff to happen in a quality manner, whether I was there or not. But that's part of the engineering aspect of what I was doing. But one of the reasons I like to have this here is because all of the equipment, like the depalletizer, the conveyor, this is equipment. And even as an entrepreneur, one good piece of equipment that's very targeted to your career or to whatever you're producing can make a huge difference in your career and your success. So this type of equipment that is used in the soda manufacturing industry enables these larger companies to produce millions and millions and millions and millions of cases of product a year, because they have equipment for it. And when you know how to fix equipment, code, program, that type of skill set is sometimes very rare, but also very valuable. Then the quality control lab. This is the lab science piece that kind of brought me to the point where I'm at right now. So as the quality control manager at this particular facility, I supervised 11 technicians and millions of dollars worth of concentrate every week. So it was very, maybe what some might call stressful or something in a way, just because there was so much at stake. There's like the health of the public, and then also the assets of the company were kind of on the line in this position. So this position included analytical testing, batching, purchasing. Purchasing is a whole job. Some people call it buying. I know you think of like buyers in like the fashion field, but procurement and purchasing is a large part of what happens in industrial engineering and manufacturing, because you've got to get the right price and the right product, and it's got to be transported. So that's a big part. Water treatment is huge in a lot of areas in the soda industry, in just in municipalities. Like how to get potable water to people is a whole orbit in itself that requires a lot. And depending on what country you're in, how water gets treated to make it potable is literally, people's quality of life is very, very directly impacted on how their access to clean, potable water. So it's a huge industry. Wastewater treatment is another thing. It's very, very big, and has a lot of applications. Then there's regulatory, like reporting, and there's certain things you can do and can't do. what you release to the atmosphere, what you release into the water, all of those things. And then, of course, there's sanitation, there's microbiology, and there's water testing, and there's so much more that goes into, what I call lab science. Very rewarding. There's research in lab science. There's innovation. There's just lots of opportunity to make a difference in a lab setting. Interesting position. I started working at another company for about a year before I started my own business, and that was in plastics. And plastics are, we think about plastics being everywhere, but plastics are everywhere. On our cell phones, like vehicle bumpers, like little small parts in the car. It's not just like kind of like cups and glasses and bottles and jars. There's plastic absolutely everywhere. So I worked for a company for a little while that assembled beverage displays. And there I managed and redesigned coolers and racks based on plastic injection molding and vacuum forming. So when you go to a grocery store or to a convenience store, and there's like, you could open up the cooler and there'd be these like racks that the sodas are sitting on, and they like kind of slide down when you pull one out. That's what that is. And so even though, when you go to a place and you go and you say, I'm going to grab this beverage here, you grab it, and again, it kind of gravity feeds down. The next one kind of gravity feeds down to you. It's like, oh, okay. But someone somewhere is doing all the work to make it flow right, to make it stand up right when it's not being utilized, or all of the things that have to happen for it to just be easy for you to grab and still stand up. And all the dimensions have to be exact. And this one is for 16 ounce, and this is one for 12 ounce. And this one is for 2 liters. And all of those things have to happen over and over again. The bottle size changes, and does it stay clean? And all of those things go into the plastics engineering. And so one of the things that's very cool when you're doing plastic injection molding is designing molds. So like those tracks, like there's a mold that has to be designed so that the plastic can fill and do the job that the engineer is asked to do, and so that the design is proper. So anytime you can design molds and formulas and stuff, that's some good design engineering opportunities there. So now I manufacture makeup. Before it was beverages, and now it's makeup. And I'm doing basically entrepreneurship and engineering. So I created a company that combines my education and experiences in manufacturing and lab science, and to an occupation that's in cosmetic chemistry. So I research ingredients, I formulate skincare, I produce goods, and all of the things that puts things on the shelf, that is innovative in the space of body care, and also the things that we use to express ourselves with color. So I'm going to demonstrate some eyeshadow making with you. One of the things I like to talk to teens about is all the things you see on Instagram and TikTok, tutorials, Rihanna, Kylie got something, James Charles. All of these things are elements from the periodic table. We have our mica, we have our kale and clay, and you can see the formulas here on the screen for these things, the manganese violet, the yellow iron oxide. This is just a small part of the ingredients, but they basically all come from the periodic table. So when you're in science class, it's applicable probably, to the things that you really enjoy the most. And that's kind of what I like to get across to students, is the things that engineering does is the things that you already love. And you can be a part of that world if you'd like in this way. So I'm going to be turning off my screen share in just a minute, but I'm going to show you that I have some safety equipment that I use. I do have a mask, but I'm talking to you today, so I'm not going to be wearing my mask because I want you to be able to understand me completely. But I will be careful. I'm using small amounts, so it makes a little bit of a difference. But definitely lab safety is the number one thing that you do in a lab. So I just want to reiterate how important that is, so that when you go and you are working in a lab and you're training and studying, that you really focus on that lab safety as the most important activity that you do. And so we are going to go into our demo. I'm going to stop sharing, and I look forward to doing this next part with you. All right, so here we are on our demonstration aspect here. And what I'm gonna do, I'm gonna just kind of tilt my screen, and you're gonna be able to hear me and kind of just see what I'm doing. I'm gonna kind of talk you through how we're doing things here. Okay, all right, so here's my screen, and I have like a stainless steel board that I'm gonna be mixing on. All right, and so I have...
Samantha, I have a quick question before
Sure.
you go. Why do you use a stainless steel board for your mixing? Does that make a difference? Were you intentional about picking that?
Yes. So so I use stainless steel. When we use stainless steel in a lot of glass in manufacturing, because it cleans the best. It's the most sanitary thing, and it's not porous. So we can it's efficient, and it preserves our assets because we're not having a lot of like pigment bleed and stuff like that. We're able to clean off our board properly for sanitation purposes and also for asset protection. So yes, that's why we use stainless steel and glass when we're doing manufacturing when we can. Mainly stainless steel is for sanitation purposes. But thank you for that question. Okay, so I have my stainless steel, and you see this is my hairnet. Now I wear a very short hairstyle, but even though I wear a hairnet, because we do this professionally, because what the things that we're doing is like what an engineer does is for the people. And so they don't know that I'm wearing a hairnet, but I know I'm wearing a hairnet. And I do that to protect their product that they're purchasing for themselves and their loved ones. And so I want to make sure that I do everything I can do to make it as healthy as I possibly can make it for them, so that they're healthy before they use it and healthy after. So this is why we do all of these things. This is manufacturing, and this is why it's important to do it in this way. So I have my hairnet on, and I also have on my lab coat as well. You can see I have on my lab coat. And what that basically does, it sets my environment up. Okay, I'm not going to come in and be making things for people in street clothes that have been exposed to the outside. So when I come into work, I have I do all of my kind of quality personnel hygiene before I get here. And then when I come in, I put on I cover, even though everything's very sanitary, I put on my lab clothes so that the only thing that's coming in contact with the products I'm making are things that are for the benefit of the product. And so that's why I do these things, and that's why it's important. And that's the manufacturing engineering piece. You can just come in, and just do something real quick. That's not what we're doing. We're doing it professionally, safely, high quality, and all of those things. That's what makes the profession professional. And that's what makes engineering such a joy to do, because you get to go through all the steps to make it amazing and excellent. So I have my gloves. And again, this is also for the benefit of the people. It's always for that. And it's also to, protect my hands because I'm dealing with pigment. So this is what I use here. Okay, or my lab gloves. Now I'm typically wear my mask, and this is going to protect my lungs and the lungs of my team from the fine powders that we work with in the form of pigments to be able to create different makeup colors that we want to create. And I have a scale. I use a small, gram scale so that I can measure and record and make the formulation to perfect precision. Again, one of the things that's really amazing about the profession is you get to be innovative and create formulas. And so what you want to do in your career is to create formulas that are, iconic or viral. Again, some of these places that I have worked before, maybe a Pepsi or a Coke or something like that, Chick-fil-A sauce, whatever the case is. These are formulas that someone has developed and has gone on for decades and centuries even. So when you're being innovative in a field like this, you can come up with something that lasts and lasts and lasts and has like benefit for you as a professional, benefit for the people because they are embracing what you've created as being something that's good for them. So the reason I said that is that's why we use a scale, because when we do that amazing thing, we want to make it over and over again so we can keep on getting the benefit from it. And so I'm taking my notes and I'm measuring everything. So when it turns out, oh man, this is amazing. This is viral. This thing is awesome. I can produce it again and again and again and again and keep on going. And I only have to really have one good thing. I don't have to have 1,000. Like just one good something, makes a whole career, makes a whole community, makes a whole state, nation, and planet ultimately. Okay. So I'm going to just be mixing some colors so that you can kind of see what that's like. And I'm going to use some Manganese Violet. And again, we talked about how, these things are just basically elements on the periodic table. So I'm going to use some manganese. And I know that this is eye safe, and all of those things have to be considered when we're manufacturing cosmetics. Is it suitable for the eyes? Is it suitable for the lips? Actually, what part is it suitable for? So have a beaker here, and I have it on my scale. Turn my scale on. You can work in grams or ounces. I like to work in ounces just because that's where I started. I started working in ounces, and so I just kind of stay there. It's kind of one of those things I started with. But grams are really good because it's a smaller increment, but I just use a lot of decimal places to kind of make up for the fact that I'm using ounces. Okay, so I have my scale, and I'm going to press the T, which means tare, and it's T-A-R-E, and it's just basically subtracting the weight of the beaker from what I'm going to put in for the Manganese Violet. So for the manganese, and again, I'm just experimenting right now. I'm taking notes. So I'm going to say, this is, let's just see what this is. Okay, this is 0.070 ounces of manganese. And so I'm going to record that. 0.70. And I check off that I did that. Okay, so this is what this looks like. All right. Manganese Manganese Violet in cosmetics it's a very soft pigment, very potent, like all the pigments are, but you can see like kind of how I smooth it out, how really smooth that becomes. And again, this is just pure pigment. This, you really, really can't necessarily use this because it needs binders and things in order to make it adhere to the skin a lot better. But this is, it's a real good one to start with because it's already kind of sticky. So like I can press it down, and like when I press it down, it kind of gets cakey already. And that's kind of what I want. I'm not all the way, where I want to be with this particular color yet, but I can see that the manganese is a good place to kind of start with. So I'm going to also, next, I'm going to use some eyeshadow base, which this is a formula that I created that helps to, make my pigments bind really closely together. So I'm going to estimate here how much I need. And I'm going to put in, let's see. I got 0.30 ounces of base. And I check that off. And I'm just going to add it to the mix. Now I'm using the same beaker really because I'm blending it all together and for demonstration purposes. But a lot of times I would take some in some, like I would have different beakers for different things, or I would be sanitizing with alcohol in between. But for the purpose of the demonstration, I'm not doing that at this point. So now I have some, this is some blue mica. And I also have some eye pigment mica, which is ultra marine blue, but this is only good for eye products and also for foundation. And I'm going to use a small amount of that also, just because I kind of want to make this a little bit more on the blue side. Okay, so of that, I'm going to use 0.005 ounces, and I'm going to record that. 0.005 ounces. And I also make sure that I record my units of measure so I know that I'm not using grams, that I'm using the right unit when I go back to recreate it again. Okay, so I have these in here, and I'm going to blend these together and show you how that happens. So I would be using equipment, but just to show you what it looks like, I'm going to blend it with my lab spatula, just so you can see what's kind of happening with it. And I'm basically combining my pigments together with my base so that I can get like one uniform color with, from all of these colors combined. And again, I would be using equipment for this typically, and not, this really small spoon, spatula. But again, when we're doing demonstrations, we like for you to be able to see the process of what's happening. So you can see as I'm blending it, it's combining. It's still streaky though. So, I know I'm not, I'm not done, or really that even close to being done, because it's still, separate, and I can see parts of the colors. And when I'm pressing these, it's, the pressure that I'm applying is like kind of crushing the oxides and the manganese and, the other elements together. I'm basically crushing everything. So right now, the color that I have and the pigments that I have that I'm mixing together are all matte pigments because I'm crushing them. I wouldn't put anything in here yet that's like sparkles because I don't want to crush that part. So right now everything is very, very mattified. It's super matte. And again, with that base is doing, it's helping to combine the pigments. It's helping to make the pigments sticky, even though a lot of them are sticky already. And it's also, diluting them somewhat. They're very, very strong. And to make it wearable, you have to put ingredients together in the base that makes it wearable on the skin, because the pigment on its own just kind of looks like it kind of rubs in and doesn't kind of sit on the surface well enough to be seen. It's really just not suitable for it. It's really, having just the pigment is for the purpose of blending. It's a raw material for blending. So you can see I got blue left in here. It's not done. It's getting there. Like right now, you don't see as many as, a lot of the parts that, they have combined somewhat, but they haven't combined all the way. But it's coming together, but I'm still seeing some streaks, but it's less and less now. Really want to get that blue combined in here all the way. Getting there. And the base is combined really nicely so far. I just still have a little bit of the ultramarine kind of that's hanging around. It looks like I got almost all of it now. Looks like there was a couple grains kind of in the top of my color. Looks like I got most of it. Oh, it's looking good. See how nice it's combining here. And so these, there's the thing about especially color cosmetics, there's basically an infinite amount of color that you can make. Because if I just change one thing, if I add one more, 0.0001 ounce of something, it changes the color. And that's the beauty of color cosmetics manufacturing, is it's so creative. It is technical, yes, but it's creative. And that's the other thing I like to make sure that teens know, is that math and science is really just the foundation behind the creativity. Again, it makes you able to repeat things and do them again and again. So the math is assisting the creation process. And so it's artistic when it's done properly, because it's basically the language of art. Some people are just so fluid in that language that they don't need to stop and take the measurements. But if you love art, but you're not so great at it, you can use math to be great at art. So this is combined really nicely, and I really love how it looks so far. And so what I would do is I would just test it and see like what I think of it. So I have like a cotton swab, and I just kind of put it here. And, from what I see so far, I like it. Okay. And the color is, looks good so far to me. Okay. But I want to add something to it. That shimmer that we talked about, because right now it's a matte, really mattified color. And so we have some pigments. This particular one is it's a color shift. So for example, when I test the color shift pigment, and if I just kind of put it on my forearm, inner arm as a swatch, it really does an amazing, beautiful sparkle like that. So I want to add this to my blend here. But I'm doing so after I did all the crushing, because now I'm just going to press it, basically kind of fold it into my pigment. Okay. Then there's another one. This one is, let's see, this one is Pearl, and it has a shifting effect as well. And so it's like when you put this on, depending on like the angle that you look at it, it shows, the color there. So that's how that is. Maybe you can see it better that way. Okay. All right. So I'm going to add a couple of these in here. So I'm going to use the first color shift, and I have like codes on here that lets me know what this is. And this pigment is quite expensive. Some of the other raw materials aren't quite as expensive as this one, but this particular jar, this is about $65, but you can use it. It goes a long way. Okay, so I'm going to use spatula, and I'm going to weigh this out so you can see what this looks like. And I'm just going to use a small amount of this here. So this ends up being 0.025 ounces included in the color shift. And I'm going to add that to my mixture. And again, I want to fold it lightly in. And you see, I'm not doing all of that crushing that I did before, because this is different. This is not an oxide or a manganese. It has sparkle, and I want to keep the sparkle. So in order for me to do that, I can't crush it like the other. So I'm folding it in, and I like how that looks. Now, when I press down on this, pressing a little bit different because it's so fine. It's nice, but it's not as tight as the other one because it's more granule. And so it kind of puts like a little bit of a separation in between the pigments. All right. And then I have this other one that I was talking about, the other color shift. And of that one, I'm going to put in, let's see. So it's actually not registering. So what I'm gonna do is I'm gonna add a small amount of the silver satin also, so I can get it to register on the scale, and so that I have something to measure. So let's see, what does this come to? Super light. So okay, I have a 0.005. Okay, and I'm going to do the exact same thing here. I'm going to add it, and then I'm going to do the same thing and just gently fold it. And this is combining really nicely, and I love how this looks. And I'm going to test it again. And let me test it one more time on this side so you can see it really good. And I really like the way that turned out. So it's kind of purpley and it has a nice shift to it. Okay, so what I'm going to do now to finish this up is I added the powder binders, but I'm going to add just a small amount of liquid binder. Okay, and I'm going to add it in drops this time, just because it's such a small amount to work with that it wouldn't register properly on the scale that I have right now. So I have some very light oil that I'm going to add to this and continue to blend it in. And so I'm going to estimate that I'm going to need 3 drops. I might need a little bit more, but we'll see. Okay, so this is a super light oil. It's a medium chain triglyceride. That's what it's called. And I'm going to put in 1, 2, 3 drops of that oil in there. And still gently folding it, I'm going to combine this very, very light binder to my powder. This is going to help it stick. And again, I have those really sparkly pigments, so I don't want to crush it. I'm just combining it now. So I'm just kind of testing it and seeing, like, if I press down on it, is it packing well? And it's doing okay, but it looks like I'm going to need about, I would say, at least 3 more. So let me put 3 more drops. And I'm going to record. So instead of 3 drops, I have 6 of the medium chain triglyceride. And I'm going to go ahead and finish combining this together. And so what's happening is you can see now when I press it down, it's kind of sticking to my spatula. Before, when I pressed down, it would combine, but it wouldn't stick to my spatula. And so that's what I want it to do. I want it to be in a form so that when I press it, it's sticking, okay? But again, I'm doing it gently because I don't want to crush anything, but I need to get that oil combined all the way. And I'm going to add, I'm going to add 2 more drops. So now I'm at 8. And like as I'm combining it, I'm making sure like I'm seeing like some kind of oily places. I don't want to see that because I need it to be all the way combined. Once it's all the way combined, I won't have that. Everything will be blended in thoroughly and uniformly. And I know that I'm ready for the final step. And again, you can see it sticking to my spatula. That's a good sign. I'm gently folding everything together, but I'm not crushing my pigment. I can still see that the oil is not quite all the way combined, but we're getting closer. All right, so we're going to give this a try and see what happens because I don't know. This is a new color. Anytime you make anything new, it's your first time doing it, you just have to try it and see what happens. Is it going to work or do I need to make an adjustment? So I'm going to find out. I can still see a little bit. Okay. Of my binder here. Not quite blended through yet. All right, so now I'm going to give it a try. This is in eyeshadow pan, and it's about the size of a quarter exactly, almost. And I'm going to put my pigment in here on my eyeshadow, and I could use it right now if I wanted to as a like a powder shadow. If I wanted to do that, a loose mineral shadow. But I'm going to press it into my pan. Let's see how it works. So what I'm going to do is I'm going to take a certain amount and place it inside of the pan and kind of tap down and some more in there. Tap it down. Okay, and now I am going to just take, this is just a thin piece of paper and like an eyeshadow, what we call a press pad. So I'm just going to put that press pad on top. Now I would typically use a weight and like a lot of pressure, but I just want to show you what the process is like. So when we do eyeshadow kits, we send out these little 2-inch clamps, and it's adding a little pressure here. But typically you can use a C clamp and really put a lot of pressure on there, or specific eyeshadow pressing tools. These are like just hand tools really for demonstration, so that you could see, kind of what the process is like, on a small kind of individual scale, so you can see what's happening. So hopefully when I take the press pad off, I will get my pressed eyeshadow in the pan. And then I would fill it again and press it again, and keep going until the pan is full. And then what I would do is I would take an empty palette and I would put the eyeshadow in the palette like this. This is how eyeshadow palettes are created, this exact way. And that is how we innovate color cosmetics. And like I would go through and probably just kind of finish, because I can see that there's still a little bit of the base that needs to be combined throughout the pigment. But basically this particular eyeshadow is a rousing success. I love how it looks. And that's what we do. And I want to thank you again for being here. And I would love to answer any questions that you might have.
That was amazing.
Oh, so glad you like it.
Yes, I really felt like we were in the lab.
Oh, that's awesome.
A science lab, because you talked so much about, you showed us the measurements, you pulled out the weight, It was definitely, I think, good to see for youth who are interested in pursuing STEM careers, especially.
Yes, I agree. Thank you so much, Carlin.
Yeah. So my first question for you is, if kids watch this and are just as amazed, how do they get started in makeup science? Or even in engineering as well. What advice would you give for them to get started? Are there any clubs or organizations? I'm sure also you mentioned that you guys have kits that also can check out and get.
Yes, that's such a good question, Carlin. I suggest, again, maybe looking into some kits like we have. But there's quite a lot of information right now that you can find, like on Pinterest and on the internet in general, that kind of does some small, like basic things to start. So a cosmetic is makeup, but it's also like the term cosmetic covers like all body care stuff. So the things I like to tell people starting off, especially teens, is start off with like a bath salt or something like that, or like a sugar body scrub. Things that have like take a process. Learn how to make some simple things with things that you can get locally. Some like the cosmetic pigments, it takes some research to know those things, and so definitely something like our kit would be a good start. We also have like refills for the kits that have the different cosmetic pigments in them. But I would start off with some body care stuff that like lets you do like a milk bath or a body scrub, so that you can kind of get into the habit of making things that are for the body in the process of what that's like. And again, there's a lot of little things that you can do. You can mix like some sea salt and some like mint tea. Like you can open up a tea bag. It's basically an herb. Mint tea is just mint, and you can kind of mix it together and make a bath with that. But that would be where I would say would be a really good start to see, do I like this kind of thing? Do I like mixing stuff together? Do I like coming up with different scents? Do I like that? And definitely want to start off with the anhydrous products, which are anything that's water free. So we don't want to really start with anything that takes water, because that requires preservative and kind of a different knowledge set than something that's like a salt, or like maybe some sugar, and like maybe a coconut oil or something like that. That's a great way to see if this is kind of something that you actually like to do.
Awesome. And then, just to wrap up,
Mm-hmm.
we would love for you to share your words of wisdom, particularly in hearing your STEM story and STEM journey.
Yes.
Thought it was so interesting how you kind of went from one area of STEM to a completely different one using the same skills, right?
Yes.
And I'm sure there was some questions and thoughts that came to mind of, should I really do this? Should I really make this change and pivot?
Yeah.
So for kids, they might experience that with being in college, and if they decide to change their major or their concentration. So just what advice would you give for kids to just follow wherever their interests lead them?
Yeah, that's such a great question, Carlin. So one of the things about like soda, it's kind of interesting, and I kind of left this part out, but the same laws that govern soda manufacturing, which is a beverage, is the same ones that govern cosmetics. So it's the FDA, and it's the Code of Federal Regulations for food and drugs and cosmetics. That's FD&C. So the thing that really helped me to kind of pivot was when it came to the one thing that I was doing first, the soda manufacturing. I did all of the things. I studied all of the things and learned all the techniques behind it. If you know the technique of one thing really good, you can almost do anything else, just because you have all the steps of something. You can almost apply it to anything else that you do. And that's the beauty, again, of knowing the steps and knowing engineering. Now, definitely going from like the beverage industry to the cosmetics, there's a lot of similarities as it relates to production and manufacturing, and like the microbiology and the sanitation aspects of it. So that is definitely an advantage to that. But sometimes you'll be watching, a football game or something, and it's the big game, and this athlete, he just caught the winning touchdown. He's in the end zone, and he's doing the thing, and he runs across the field, and he does like a round off with a backflip on it. It's like, how does this athlete that just ran out of football, like, how does he do that too? And it's just because he's really, really great at football. He's strong, he's got endurance. And so even though that's not his thing, he does the other so well. So I would just say, whatever you're interested in, do that thing and let that lead and take that skill set. And you're probably going to want to stay in the same thing. It might not even seem like it at first. It might not seem like that soda and skincare are the same. But if you do that one thing and your interests change and you're pivoting, you'll find the parallels and be able to apply the things that you learned in the skilled position here into this skilled position.
Love it. Literally drop mic. Well, we want to thank you so much, Samantha, for being our speaker tonight and sharing with us about engineering and makeup science. It has really been a phenomenal presentation for those that are interested in STEM to see.
Thank you so much for inviting me. Thank you. I really appreciate it. And thank you all for the work that you do to help teens see that they can choose STEM, and it can be rewarding, it can benefit humanity, and also benefit them in their personal lives. I appreciate you all's work as well.
Thank you. And thank you for making our favorite color purple.
I thought that, you know what? I was looking down. I said, oh my gosh, that's sunlight colors right there.
Even though I cannot put on a purple eyeshadow that great. So it's like, now I got to learn.
Now you got to learn for sure. That's right.
Well, thank you so much for, I said, it was a great presentation. Carlin has put the survey in the chat. So whether you're watching it live now or over YouTube, please take a few minutes to fill out the survey. But again, thank you so much, Samantha. I mean, we learned so much. And I'm an engineer by training. So just to see how, I tell people all the time, if you can be an engineer, you do anything. And just seeing that with your career shifts from colas to cosmetics and just getting that scale and showing the importance of PPE, right?
Yes.
So thank you. So thank you again for giving time to show those that if you like makeup, if you like skincare, and you like science, you can have a career making makeup, right?
That's right. Thank you so much.
All right.
Thank you.
And see you all at the next SCM Link event.
Thank you.